I have prepared also a showcase of the IC, and I think it's interesting because when I show you the code, you are going to tell me, Tiago, like this is what I do every day. Like this is normal TypeScript. This is normal like React. Like how is this the blockchain? And I think I can only explain you on this first part. Why is it, although it's being compiled to WASM and it looks so easy to code for the IC, why you should be aware that you have a very different operating system running underneath the hood. And you need to be aware that you are going through consensus when you're making these calls. The update calls is going through 13 nodes and stuff like that. Okay, and I think this presentation is more towards that. Let me view full screen. So in a short sentence, because a lot of people ask, what is the IC? What is Internet Computer? I think a really good way that starts a good frame, because the IC is very complex. It has many, many functionalities, many features. But I think a good way for you to see is like it behaves like a decentralized and permissionless cloud. But built on blockchain technology. Try to think like AWS, and maybe you already had some interaction. I know you're just coding, or starting to code, but maybe you already deployed because I don't know if 42 School has this credits partnership with AWS or with Google Cloud, but usually they do. They allow you guys to deploy a machine for free and play around with a small machine. So try to think that it's the same thing. Like you're just deploying code to a web server, but on the case of the IC, because it's meant to be decentralized, like the infrastructure to be decentralized, you just deploy the code. You are not, like the developer is not supposed to be very in small detail care about how is this going to be global, robust? How can this machine scale horizontally or vertical? How can this deal with more requests? Like you don't need to load balance anything. It's a lot easier, and the way that you pay your bill. Be aware that compared to other chains, DIC has the concept of reverse gas model. And what it means is more that it's just like if you are paying to AWS, you're paying the time that you are using. In the case of the IC, you're paying the update calls and the storage that the WASM, this canister, is costing you. And you, the developer, are paying for it, or a community can actually pay for it. On the example that I was giving of the game that I have, like anyone can pay for that game. They just go open the ICP tophub.com or something like that, and they just write the address of the canister of this web server, and they pay for it. So try to think it's a cloud. It's a decentralized cloud. It behaves a little bit different from AWS, but it should be the same for you to interact with everyone else, okay, in the browser, as I'm going to show you with some examples, okay? Before I continue, already Tom had a few questions. Okay, Steve. What do you mean blockchain and blockchain? Could you talk, Tom? Feel free to talk. What do you mean blockchain and blockchain? Could you clarify? Typo on your slide. Oh, actually it is. Okay. Yeah, you're right. These are all the slides. I've corrected it on the other presentation, on a more recent one. Yeah, it's blockchain. Okay, sorry. Built on blockchain technology. There's a typo there. True. Well catched. So moving on, I think a good perspective is how different generations and how, although this is the crypto industry, how they actually help each other and how they are architecturally very different. So the first generation is definitely Bitcoin, cryptocurrencies, and a lot of them appeared. And if you go to the architecture, they're just solving the double spending problem, and it's a shared database ledger underneath the hood. It's very focused on that, and their purpose is to be a cryptocurrency. It was a purpose of Bitcoin, and it's decentralized. It has store of value, and then it's interesting that Vitalik was frustrated. He was very part of the Bitcoin scene, and he wanted Bitcoin to be kind of a world computer and wanted it to carry logic. You know, it's not just transacting. You wanted to do something more with it, and he wanted to change Bitcoin. He really wanted. He was very frustrated in the beginning, but then out of that frustration, he understood like already it's too much to change the architecture of Bitcoin and so on. So definitely let me build something else that is less risky, and then people start to see if this is actually useful or not. And Ethereum was born. The white paper was born, and so on. So out of that frustration, we have another purpose. And in the case of Ethereum, this second generation of blockchains, the purpose is more you not only have the transaction, but you also have a consequence after that transaction. You do a transaction and then an NFT comes to you. You do a transaction and then you have voting power over something. You kind of receive a token back. You know, you do an ICO and then you have paid in a certain coin, imagine Ethereum, and you received back another token. Okay, so these kind of consequences and also DeFi is the same. Like I'm staking my coin, and then because I'm staking, I'm blocking my value there. I'm locking it there. I am entitled to receive interest later on and stuff like that. So you see, it's always transactions, constantly happening on the Ethereum network, and with those transactions have some consequence. Okay, but already this added a lot of really cool stuff. We had ICOs, DeFi, NFTs, stablecoins. Many of these names are familiar to you, and many layers twos, many other blockchains appeared after Ethereum, and but mostly the or even before, like Cardano, for example, started before. But the focus is the same. Like there's some frustration on only having transactions. Let's add logic, and how can we actually make this logic very cheap and very fast and scalable? You know, and many of them deal in different architecture, but they're trying to solve the same problem. Okay, transaction, logic, purpose. Now, the third generation, I think the IC is trying to bring in something new to the Web3 ecosystem. It's a more general purpose blockchain. Try to think it like that. Like it's a general compute blockchain. It literally allows you to do anything. It allows you to do transaction logic purpose, cryptocurrency purpose. It allows you to do anything. But because it's more general, it's also, I would say, even more complex. It definitely took more time to be built and how to actually make it balanced and safe and so on. So it's very much more complex. Um, and also even for the developer, like you can do whatever you want, and sometimes it's risky because on Bitcoin, like that's the behavior. It cannot be changed. It's safe, and some people want to store their value on Bitcoin because it's consistent. Like there's no way that the behavior is going to change. Now on Ethereum, we had already some upgrades, and in the future we'll continue to have upgrades. On the IC, things are changing constantly, all the time. Be aware that there is a new IC version almost every week. Okay, so it has nothing to do. Like the architecture is meant to be for the general purpose blockchain, a decentralized cloud, much more powerful, much more complex. infrastructure around it. And then you ask me, and what does it do? It allows for open services. And by open services, try to think like DAOs, but that already Ethereum and several other second generation blockchains already have. But in the case of the IC, they are a lot more powerful. Okay. And they can hold everything on chain: code, secrets, API keys, emails. It has random, it has timers, it can, yeah, do a lot more than and a lot cheaper and faster and scalable than a transaction logic purpose that it inevitably limits you how what things you can do. Okay, because of the architecture. Okay, it's more like that. It's not because people don't want it. It's there are some decisions that to avoid them. It's very hard. Okay, that's why I think that there will always be a space for a second generation blockchain and always a space for a first generation blockchain. I think Dogecoin will probably live forever and ever. That's what it is. But a third generation blockchain, it will always be around as well. Like it will add value on their niche. Okay, the same as these other ones were adding value on their niche. And yeah, there's also alternatives. Several people are trying to make things more integrated, but I would say in different, like in the details, the architecture and the way that you are doing stuff is different. Okay, but that's not for this talk. So I hope that for now you already understand that the main purpose of the IC, at least in my personal perspective, is to be the complete, like the completion of Web3. The vision of Web3 is finally possible. That is for a community controlled environment that is fully open, fully transparent, and allowing you to build a fully decentralized ecosystem that you can have fully on-chain dApps, but also data, also external interactions, even with the browser. You can hold secrets like API keys, emails, and you control code, as I'm going to show you in a minute. So the first example that I wanted to bring you, I have, call yourselves, 4 different examples. But the reason why I'm showing all of these examples, if it's too much, please let me know. I could go a lot faster. But the main thing is to expand your mind into what you could be doing in the future. Because I can show you the code, but yeah, I think it's limited. Like, I think what you should also be thinking is what I'm going to code on. And I think a lot of people are going to code the next DeFi. Come on, you on the internet computer, I can actually do a lot more cool stuff, and that's what I want to showcase to you today. Okay, so OpenChat, for example, I think it's one of the most interesting and even successful projects on the IC. Let's go to personal accounts to show you this. OpenChat is a mix of Slack, Discord, Telegram, but 100% decentralized on the servers of this network. That, let me actually show you. Like, there are many nodes, many independent data centers running the code, the WASM that I was talking about. And the idea here is, and also be aware that they have machines are standardized. It's not like me with a simple computer to actually become a node. That's different from many blockchains out there. The IC has decided to maintain consistency so that people can always have this experience of a 2-second finality on the update calls and around 200 to 400 milliseconds on the query call. So pretty much I can load the website, or should be capable of getting like feedback from the canister in very quick time because it's a query call. Let me actually show you that. Network. Yeah. You see, it's even because it's actually free. the query calls are free on the IC for now, because it's cache. It's constantly hitting cache and coming back. And for now, it's free. They're not paying for the bandwidth. But any update call that I make, it's going to be it will have some cost, okay, and then it needs to have a business model around it. So in case of the OpenChat, they actually have premium account and stuff like that, and monthly base and lifetime payment and so on. But what I wanted to show you is that although here is OpenChat.app, a normal domain, underneath the hood, this is actually going to the boundary node, and then the boundary node is asking on the canister, like HTTP method, HTTP request method, what should I return? Like these are the inputs, the headers, if it's a post call, if it's a get call, whatever, return me the response. And it's constantly returning. And the boundary node sends you back. And you know that this is safe, that is coming from the right boundary node, that it was not tampered with, because there is a certificate. You can actually be sure that there was no middleman in here and things were encrypted and stuff like that. So it's really cool that you can actually load a website from a canister, from a smart contract on the blockchain. And let me close this. And for example, in the case of OpenChat, you can store messages that I'm talking with people. I can, like the images that I send can be on my canister. Yeah, I wanted to show you, like I have a user ID, like a person has a canister ID, that's I am the only person that is controller, and also the index canister to constantly upgrade stuff. But also the index canister is controlled by the DAO, and OpenChat is a DAO that needs like everyone's approval to do certain actions. Imagine to upgrade the code. And here, for example, is how you can see, many DAOs, that they are almost dead because you go to Snapshot, you go to some of these off-chain voting systems, and they don't vote that frequently. And the reason for that is because they're not relevant, the proposals. Like you cannot do that much with the proposals, to be honest. But on the case of internet computer, not only they are relevant, they are required. Like it needs to. If you want to change any code, you cannot just deploy it. And sometimes you have a hotfix, and it's a little bit worry. But yeah, like that's the cost that you pay. Like if you want to upgrade, you need to update. For example, this is a good case. Like people need to adopt, and hopefully, like people just understand. They can even verify what was on the hash on the GitHub. They can see the code, what is actually was changed, and you can have external reviewers, a bounty program on top of this, and so on. And the main idea here is that a DAO fully controls what is happening, okay? And it's fully transparent. Even if it goes bad, at least someone can go there and check, what's happened. Yeah, so pretty much, I think that's a great start on what the IC is capable of, that I think I showed you. So the other ones should be quicker. Let me go back to the presentation. The second one is on Decide AI. So another use case that is not DeFi. This is actually running AI models. We are still a little bit long way to go, okay? Not gonna lie, like we are not already the best place for you to put your AI model, because you always need to run through 30 nodes to get the answer from the AI model. And for quick chat with an AI, it's not really the best. Like, you don't want to wait 13 machines to agree on something. So, and also sometimes, actually on the inference, they can be more discrete, like they can always agree on the same thing. But actually, in normal cases on AWS, Google Cloud, and so on, many times, if you ask the same question over and over to OpenChat, sorry, to OpenAI, to ChatGPT, you get a different answer. And the reason for that is because it's not discrete. Like it's just the way that it's running. Normally it goes other places. So I wanted to show you. It was too fast. So in this demo, you can see she is recording a video. This front end is actually on chain. That's a really cool part. Like it's fully controlled, and it's a canister, and she's recording this experience. And after she stops the recording, it's going to be sent to the backend to a canister. And this canister has an AI model on it. And actually, it's a network of canisters. It's a little bit more complex. But try to think that in the end, the video, it's just an input. Then this input is being processed by an AI model that is recognizing the face. Is actually a human person, and if it is a human person, let me create a hash that is actually unique and store it and create a credential on top of it. And if someone comes here tomorrow or comes here in the next year, the AI model that is discrete will actually arrive to very similar hash. And based on this very similar hash, you can say, no, you're not unique, like you have come from this recording in the past. So I want to refuse your request to get the credential of being a unique human. And this use case I want to show you because it's worth paying the 13 machines to agree on, because I'm only doing KYC, from time to time, maybe once in this platform. And it's worth it. Like it's worth the robustness, it's worth the secrecy. Like someone recording your face is maybe a little bit sensitive, so it's not reused in whoever is doing the same KYC for another platform or something like that. It's a little bit sensitive information. So definitely you want the safety of the blockchain. Okay. Yeah, and pretty much then she's just showing that she can use the IC on the OpenChat. On the case of Internet Computer, we have verified credentials already. There is an implementation of decentralized ID. And yeah, that's pretty much how it works. The people can, on OpenChat, unlock airdrops and stuff like that after they prove that they're human and not a bot. Going back to the presentation. So the other ones I'll be more quick. This is another example of being an AI. So this is actually an address of canister that this AI is stored, and it's very limited because it's for free. Doing update calls, and they are still working on having paid versions that people would actually pay to interact with and have bigger models on chain. Yeah, here can you kind of questions I can ask. So the future, and I want you to also get out from here with that perception. A lot of people are talking about AI in the moment, and one of the narratives out there is that the future is not going to be a single model like Red Eye coming maybe from somewhere with bad intentions that will spy on all of us and be super powerful. Actually, the reality is probably going to be a network of agents that are very specialized, the same as humans. If you think about it, like when an organization wants to grow, they're not going to put more hours into a single human and that's it. No, actually, you end up having teams, and then teams of teams, and then heads of heads and stuff like that. So in the end, you end up having a structure where you can have a network of decentralized agents. So in the future, something that also is boding well for the internet computer is that we'll probably have a network of canisters, each or many of them deploying their own specialized, very good agents on their very specific areas that can be cheap because they are very good in that small kind of questions. And on those kind of questions, they can be very accurate on what they are doing. Yeah, and in this case, it took a little bit to get the feedback, and she can only answer about this. If I ask something like, "How is the weather today?" She won't be able to say. Okay, and if you go to OpenChat, to ChatGPT, maybe they can do, because they have an agent that is actually connecting to the internet and handling maybe some this kind of information. Okay, yeah. So I showed you already this example, but it's looking promising, and ELNA is about being an agent marketplace on this decentralized potential future. And people can have a developer studio where they deploy their own agents and ask for a certain payment. That is still being development, but they can ask in the future for payments. Moving on. Then you have maybe my favorite category, that is about games. And on here, it's also more dynamic on your side. Feel free to just write on your browser thecubetopia.com, and I think you will have a similar experience as me. Try to see how fast that was. I'm going to refresh. That was really fast. And yeah, so people are joining. Hello, hello. Maybe some of you are from this call. And here we are playing, and the cool stuff about it is that the canister, this is an example of Hazel and TypeScript that I was also talking about. It's 3JS. It's very fast, much better than Unity, WebGL. In this case, it's fully TypeScript, so it's 3JS in the front end, Hazel in the back end, storing the save state, storing the user, storing the leaderboard, storing all of this kind of information. And because it's a multiplayer game, and it was very important for it, that's the only thing that is actually not on chain, is the positions of the players. For that, Joey is using DigitalOcean and constantly using a single web server to keep track of all the updates of the positions. Okay, so that's the only thing that is actually not on chain, and the reason for that is because update calls will take a little bit longer, 2 seconds, and that's too much for a position. And also the value of it is very small. Like, why would you pay for a position? It's just a position of a player. Like, it's completely worthless, from the blockchain or value economic perspective. But yeah, so yeah, feel free to play. Someone is already far away. Cool. So going back to the presentation, another example of also update calls. This case is more towards the creator economy kind of example that I think the IC is very well positioned to go. In this case, it's another fully on-chain game, fully decentralized game that can live forever, all these kind of things. But in here, the players can 100% change the game. And it should go through a DAO, okay? But this DAO eventually, imagine that it earns money in the future. That is not happening right now. But imagine that it earns money in the future. You can exactly see who proposed what and what did the person actually interact more and what the algorithm chose, like what scenarios, what text, what images, what races, even avatars did the user speak. And based on the frequency of being used, an algorithm could calculate what is your contribution, and based on your contribution, you could have a share. And this model is very similar to how you have stuff on Roblox, Minecraft, and so many others that have add-ons and created economy on top of it. But the best part is that it doesn't have platform risk. That's the very big difference. You don't have platform risk, and you also, it's easier that these actually can live out on its own. Like even if the developers are dead, like it can develop on its own. I think it's really cool that this kind of contribution system and cooperation system could actually live on the IC. Like in theory, it's all there, but it's not so easy. And yeah, so pretty much it's on the roadmap. But for now, you can already change content, and I think it's really cool. And you can go to the DAO and modify game content. You can create, after you log in, you can create your proposals. You can request to edit and improve certain proposals, like a certain scenario that you are playing. Yeah, I'm not going to show you. You can explore it on your own. But try to think that it's a decentralized game that can have decentralized contributors and decentralized content, and can, if you do the algorithms right, it can quickly work on top of each other and kind of capitalize on these small gains. And after a while, I don't know, maybe 1 year or 2 years, this is much better than Roblox because it had a huge network of people that were interested in contributing to the game. And that's it. That's actually the last one. This is a practice time. Also for the Q&A, I will be now discussing more Q&A before we go deeper into the code. Feel free to do QR code or just write on your phone or on your computer, icpsavior.com. This is a game, it's a demo game of the IC, and it is going to explain you more features of the IC. You need to kill the trolls and save ICP from trolls, and learn along the way some cool information. It's like an educational demo kind of game. And it's fully on chain. Like this one, I know that it has like 60 megabytes. It's very small. It's all game. It was built in like 4 days, by a friend of mine, Temo. And yeah, it's like 60 megabytes. It's not much in storage, and the cost of it, because it's query calls all the time, it's free. It's taking like 2 to 3 euros if I progress it for the entire year. 2 to 3 euros to store a game online. It's just like the domain is more expensive. The domain icpsavior.com is more expensive than the hosting. If you're paying by the second to have a web server machine in any cloud, it's going to cost a lot more. And the big difference of it is that the IC, if you're more technical, maybe you ever heard of serverless functions. And the big gain is that you're actually only costing something when you update the state. Outside of that, it's just storage, and storage is quite cheap. So that's why this game, this specific and static pages, they can be really, really cheap on the IC, because it's just deploying it, and then people are just querying it. And as long as the majority of people are just querying, you can have a startup very, very, very cheap, much cheaper than if you would go to AWS and the rest, because yeah, it's just storage. It's not actually processing. But on the other case, if you are doing a lot of update calls and you're like an middleman of constantly updating information, like that can be quite costly, because you're constantly checking. And if the information is actually worthless, I don't think that's a good idea to bring it to the blockchain. So don't think that we are going to tokenize the world. Everyone is saying that. And like everything is going to be on the blockchain and everything is going to be decentralized, maybe in 10 years time. But for now, like every niche has their own things that they're very good at. And yeah, if you're making constant low value updates, definitely use AWS, the normal Web 2 world, as much as possible. Yeah, I would say. Okay, so I hope that this was a very deep dive. I know that it took a little bit long, but I'm open to have questions.